Hey everyone, next up we have Aidan, founder of Snowfork, talking about bridging Polkadot and Ethereum interoperability today. I'll let you take it from here, Aidan.
Cool, thanks. So hey everyone, I'm Aidan working with Snowfork, and we've been building interoperability between Polkadot and Ethereum. And so I'm going to talk about our project, how it works, how it looks, and how we're doing today, and what you can look forward to in the next few months, and seeing how we'll be bringing tools to bridge Polkadot and Ethereum. So let's get started. So what is Snowfork? Snowfork is essentially a collection of designers, developers, product managers, and researchers that work together on a bunch of different projects. And we're kind of like something like a community / agency / dev shop hybrid. We've been working together in different industries for a long time on different projects. And specifically in the blockchain space, we've been interested in interoperability. And we've done a lot of work with different chains. But this year, our main focus has been bridging between Polkadot and Ethereum, and we've been working on this bridge project. And so I'm going to talk a bit about the kind of design space of bridges and the way we kind of think about them philosophically, and then get into some details about our bridge and where it's at today, and then just talk about the roadmap, how different teams can look to integrate with the bridge and interface with Ethereum, and then can get into some like more deeper technical details at the end if we have time. Cool. So I think when it comes to interoperability and bridges, there's different designs that a lot of different teams pursue, and there's trade-offs between the trust dynamics of the bridge, the cost of the bridge, and the user experience of the bridge. And so, for example, you can get bridges that depend fully on cryptographic proofs and are fully trustless, but they may have additional costs or kind of user experience compromises in terms of how long it takes end users to interact with the bridge and confirmation times and delays. And then you get the other side of things, like bridges which are fully centralized, which, if you're familiar with like proof of authority and Ethereum, they're where you're kind of basically trusting the operator of the bridge. And then you get kind of places in the middle of the spectrum where there are kind of centralized parties that are involved in running the bridge, but they place some collateral or kind of stake that can be slashed that gives users some protection against having to fully trust them. And so I think when we think about bridges, there's this space of trade-offs, and then there's also these different use cases and products that will be built upon bridges. So there's basic ones like asset transfer of assets and tokens between Polkadot and Ethereum, as well as more complicated applications like, for example, swapping tokens across chains and kind of debt-style transactions across chains, all the way to the end where like full, complete hybrid applications where some part of the application lives on one chain and another part of the application lives on another chain, and you've got kind of cross-layer applications, whether it's kind of using Polkadot as a layer 2 for Ethereum, or kind of fully hybrid applications that determine which chain they want to support their logic on. And so kind of depending on how you design your bridge and the mechanisms that you choose to use, you're going to be at some space in this trade-off triangle that supports some kinds of applications better than the other. But with our bridge and kind of our core target, specifically with like Polkadot and the cryptocurrency ecosystem, is trust minimization. And so the way we think about at least this initial bridge is that we want to prioritize trust minimization and decentralization as our goal for where in the trade-off space we want to lie. Similarly, we're kind of hoping that our bridge will become kind of like a system parachain that a lot of other teams end up using, and that is built to kind of support the whole Polkadot ecosystem. And so this has additional kind of goals that we want to kind of achieve for that. One is that we want a kind of modular and componentized setup with clean interfaces. So although we talked about kind of the most trust minimized target being our first target, I could imagine in future that for different applications and teams, being able to play with that trade-off space will become important to them in order to optimize for user experience or cost or whatever. And so ensuring that we've built things out in a modular, componentized way that allow other teams to kind of start extending modules and components to explore alternate places in that trade-off space that fit their needs best is an important design goal. And so that modularity is part of it. As I said, trust minimization and decentralization is another kind of goal of ours. And lastly, even though we're kind of focusing on that like trustlessness and decentralization as our core target in that trade-off space, we still want to end up with something that still has a reasonable cost and reasonable user experience for like our first version, such that both end users and application developers can still actually use this thing in practice, rather it just being kind of a proof of concept that is not actually usable in production. And then lastly, we're building a bridge to ideally support arbitrary states and to be agnostic to the application. So some bridges focus on transfer of assets, for example, transferring ETH back and forward or transferring ERC20 token back and forward. We're trying to build our bridge in a way that will kind of be more agnostic to the application, whether it's asset transfer or kind of hybrid logic or a DEX or a game or whatever. Cool. So now I'm going to dig into kind of our trust mechanism that we're using and how it works, and then get into the architecture of the bridge as a whole. So I think the core thing to understand how we are gathering trust in the bridge is through Lifeline verification. And so I'll give a high-level overview of what Lifeline verification is, and then get into the details of our two Lifelines. And so with Lifeline verification, the goal is to essentially build a Lifeline that runs on-chain on both chains that is capable of reading states from the opposite chain. So on Polkadot, we would have a pallet that contains the full business logic for an Ethereum Lifeline, which essentially means that Polkadot on-chain is capable of reading any state from Ethereum. And then similarly, on the inverse, we're looking to build a Lifeline within a set of Solidity smart contracts that are capable of verifying Polkadot. And so the kind of main difference between a Lifeline and a full node is, so usually if imagine you're running Polkadot and you're participating as a validator, you run a full node, your responsibilities are to go and produce blocks and finalize blocks and run the full consensus process. Whereas with a Lifeline, conventionally a Lifeline would connect to a full client and watch updates that are happening to the chain, but would still run kind of the necessary cryptographic checks to verify that the chain is moving forward correctly and that consensus is happening correctly. So in the Polkadot side of things, because Polkadot runs on proof of stake, kind of a Polkadot Lifeline would not need to produce or finalize new blocks. It would just need to validate that the blocks that it's seeing conform to the correct rules of the proof of stake consensus algorithm and block production and block finalization. And so it knows that when it sees new blocks and new state come in, it can detect and determine whether or not those new blocks are valid and whether or not those new blocks are actually likely to be included in the Polkadot chain. And similarly for Ethereum, a Lifeline needs to kind of verify the proof of work and ensure that it's a high enough difficulty that implies that it would be on Ethereum mainnet. And so the way Lifelines work usually is under this kind of watch/pool model, where they're watching full nodes and seeing data come in and then forming up their own conceptions and opinions about what's going on the main chain. But because we're trying to do this on-chain rather than off-chain, the kind of model changes. And so we essentially need data to be pushed into these Lifelines. Once data has been received by the Lifelines, they're kind of still back to the conventional business logic where they're verifying kind of consensus and progression of the blockchain. But that kind of push model does change some of the dynamics of it. And so when it comes to our two Lifelines, we've got the Ethereum Lifeline pallets. So this is going to be implemented as a pallet in Rust on Substrate. It will have extrinsics that allow it to receive messages of updates of the Ethereum state. And so it will follow the latest Ethereum headers after a certain amount of confirmations that can be configured. Whenever it receives a new header, it will check the proof of work on chain via generating kind of from Ethereum's cache and the kind of graph that's required to check the proof of work. We can get into details about that later if there's time. And so that allows it to kind of follow the longest chain and keep up to date with the longest chain on Ethereum. And then in addition, it will be able to check proofs of specific transactions and transaction receipts to confirm that specific transactions have been included in the chain and possibly confirm specific events that have been included in the chain. Similarly, on the Polkadot Lifeline side of things, we're developing a Lifeline in Solidity that will run as an Ethereum contract on Ethereum and accept messages that allow it to similarly follow the kind of Polkadot longest chain that's been finalized via Babe and Grandpa. when it comes to kind of extending the longest chain and following along as proof of stake consensus progresses, it's going to be checking the proof of stake signatures of the validator set and kind of progressing as the validator set changes and produces a new block. But as many people probably are thinking, like, oh, we're doing this in Solidity, there's going to be high gas prices, it's not going to work in practice. And so that's kind of correct. And so there's a few additional ideas that we are kind of extending the Lifeline with on the Ethereum side to kind of save gas costs and to make it actually practical in production. So the kind of two main ideas here is that we're working with the Polkadot team to add an additional gadget on top of Grandpa and Polkadot, and not just, this is something they may have kind of mentioned. I won't get into the details of this now, but if there's time at the end, we can discuss them. But essentially, we're hoping that there'll be an extra gadget added to Grandpa and Polkadot on top of the core consensus that produces additional Merkle Mountain Range style routes, which allow us to essentially skip blocks ahead, such that instead of the light client having to go and verify every single block and every single consensus change, there'll be kind of this aggregated summary of changes that happen that we can skip to, say, every 10 blocks or every 20 blocks or whatever we parameterize it with, to avoid having to check every block. And then similarly, a second savings is that instead of needing to sample the signatures of every single validator whenever there's a change, we will have a kind of random sampling process whereby we select kind of a random subset of the validators and sample their signatures and avoid having to sample all of the kind of signatures for validators. And the details of these, as well as like how it works and what a Merkle Mountain Range is, if you're not familiar with, I think if you go and Google that term, you'll find some information on it. But if there's time at the end or over Discord, we can also kind of discuss some more details there if people are interested. And so everything I've talked about so far on this slide is purely about how we get people to trust the bridge and why people should trust the bridge. But it doesn't kind of talk about our architecture and how things actually fit together and how things work in practice. So I'm going to talk about that next and fit the kind of idea of the light client trust into the bigger picture so that people can understand how trust is achieved for the bridge as a whole. And so, yeah, so when we look at our architecture, we're designing kind of a layered architecture where there's this barrier between the bridge layer versus the trust layer versus the application layer. And so if you look at this image, you can see on the left, there's a substrate pallets. On the right, there's our kind of Ethereum Solidity contracts. And each of them, they have these three separate layers, the bridge layer, the application layer, and the trust layer. And so if we zoom in on the substrate pallets on the left, the bridge layer is essentially a pallet that is responsible for kind of keeping the bridge up to date, for following the longest chain on Ethereum, for incorporating new headers and up-to-date state there. The trust layer is where that light client logic lives and where kind of verification of the longest chain through proof of work verification happens, as well as verification of specific transactions and events that are included that the bridge cares about. And that's kind of generic and abstract to any particular application. But once an event is received, after it's been accepted into the bridge layer and verified through the trust layer, it will be routed up to the application layer. And so as an application developer or someone that's interested in integrating with the bridge, by the time the kind of state gets to you and your application layer, it will already have been verified and kind of already can be trusted. And so that kind of obfuscates and abstracts, or not obfuscates, sorry, abstracts a lot of that complexity out of the application layer. And in a way, this kind of design is similar to the conventional networking stack, where if you look at the green arrows, those represent messages that are moving up and down between and communication between the app layer and the bridge layer. And so you can imagine an application will kind of send out messages to the bridge layer with the expectation that they will eventually get delivered to the opposite chain, as well as receive messages from the bridge layer with the expectation that they have come from the opposite chain and that they're correctly verified. Then you've got kind of the red arrow between the two bridge layers, and that represents like the core underlying bytes and data that are actually moving across from one chain to another. You've got the blue layer, which is the trust layer, and that represents the kind of communication between the data that's stored at the bridge layer and the kind of cryptographic algorithms and proofs that we need to run to check that data and verify it's correct. But then kind of the most interesting one is actually this orange one, where it's a more kind of abstract conceptual form of communication at the application layer, where if I'm an application developer, I may have some logic that lives on Polkadot and some logic on Ethereum. And then I have within my application a set of interfaces that allow my Polkadot part of my application to communicate with my Ethereum part of the application. So you would have kind of an application layer interface here that is abstracted away from kind of the lower level details. But when you're developing an application, you kind of mostly just need to think about how you communicate with your two sides of your application at the application layer in a conceptual way. And similar to kind of the networking stack, where you start with, like, for example, a website in the browser where it's wrapped up in JavaScript and then gets unwrapped into HTTP and moves down to kind of the network layer and is turned into packets that are sent over the network that are then sent over to another computer and wrapped up again, eventually till they get back up to HTTP. When you're a kind of web developer developing a website or an HTTP application, you only really need to care about HTTP and about the specific choices that you make within your application, because all that lower level stuff kind of is handled for you, and the communication happens through those low level protocols. So that kind of same analogy applies to us. Yeah. So kind of that's the kind of high level conceptual layer of architecture. Then when it comes to actually interfacing with our bridge, we're going to have low level APIs for devs that want to build their own custom applications and kind of interface directly with the bridge layer to, say, add support for new kinds of transactions and events that their application needs, as well as high-level APIs for end users and for kind of application developers that just want common use cases. So we'll have, we're in this kind of bridge layer when we launch the bridge, we'll also have some specific applications that have already been built, for example, to transfer Ethereum back and forth and to transfer ERC20 tokens back and forth. And so as a kind of developer or end user, if you're interested just in token transfer or asset transfer, you can integrate with these applications at a higher level API. And these APIs are going to be available via cross-chain message passing for other parachains to integrate with, whether they want to integrate with a lower level or higher level API. And kind of, so that's how things look at a conceptual level. But in practice, there's a lot more pieces that are involved in actually making this thing work. So there's a relayer and the parachain correlated nodes and different incentives and guarantees that are involved. And so firstly, if we look at the relayer, so that would be this red lower level layer between the bridge layers where there's actual data being moved around the internet. And so for there, we have a relayer service that's a separate service that runs. It's going to be fully trustless and permissionless. And so unlike some other bridge designs where you need like a set of signers or validators that need permission to relay data between the two chains, ours will be permissionless and trustless, so anyone can relay, which means that users don't actually need to trust a set of parties to, or a set of validators to do this relaying. And if an individual user or individual application developer doesn't want to trust anyone, they can also just run the relay software themselves to relay messages across and kind of ensure that their messages specific to their application get relayed in a fully trustless way. Having said that, we still want to have like a clean, nice user experience, and we want to ensure that there's kind of high quality, always available relaying happening. And so there will be some rewards and incentives to kind of incentivize the relayer service. But these incentives are kind of an extra layer on top of the core bridge protocol. They're not like really core to the protocol or required for the functioning of kind of the trustless bridge. And so they could come from kind of a non-profit funding source. They could come from like a separate business that does in additionally, or as I said, they could be done by individuals who just want to relay themselves for their own applications. Likely to have a custom token. The parachain will run on dots. It will kind of participate in the like creation of blocks through dots being locked up and be funded through a pool of dots that we're hoping we'll be able to kind of proposition the community and the treasury to fund. as well as a fee model where users that are actually using the bridge and kind of applications that are sending messages back and forth across the bridge will have some kind of potential fee that will go into the kind of treasury of the bridge that's used to kind of fund ongoing functionality and running of the bridge. And similar to the relay, we're kind of hoping that we'll be able to be fully trustless and permissionless here in terms of allowing anyone to run parachain collator nodes and anyone to produce and submit new blocks. But there's some kind of complexities here. And so whether or not this will be possible is still to be confirmed. So we may end up needing to have some kind of permissioning through stake of who can run parachain collator nodes here, and there are some implications there for trust, but we're hoping that it will still be able to be mostly trustless and permissionless as we kind of work to design this out. I think also with kind of parachains in general, it's still kind of a new space where Cumulus, the tool that's being used, being create parachains and kind of the different mechanisms that parachains have available to them, whether it's proof of stake or proof of authority, or this kind of trustless, permissionless, deterministic design that we're thinking of, are still to be defined. And so these details will get ironed out over the next few weeks. And so related to that, the rewards and incentives for running parachain collator nodes are going to be dependent on this permissioning model, which is still kind of being defined. And so then if we look at the architecture overall, this kind of image represents our architecture as a whole. I'm going to kind of quickly run through it to get a sense of things. So the blue on the right is the Solidity contracts and the Ethereum side of things, where you can imagine our Solidity contracts are running, and there's an Ethereum full node which has our contracts. Then there's the green relayer service, and it watches the Ethereum full node through kind of the blue arrow, and whenever it sees new Ethereum events or transactions, as well as new blocks and proof of works being produced, it submits a transaction via the green arrow going downwards to the left into our parachain collator node. Those green messages are get interpreted first by our substrate pallets and are submitted as an extrinsic into the bridge layer, where the bridge layer kind of unwraps those messages. It works with the trust layer to check the proof of work and to essentially extend the longest chain. And then it also accepts individual transactions and checks again with the trust layer transaction inclusion proofs. And once it's happy that a transaction has successfully been included and convinced, it sends that message up to the application layer, which is here in orange. And so in the application layer, there's our specific applications which will be used for kind of asset transfer, for example, moving ERC20 assets back and forth in Ethereum. And so there'll be events there related to like burning tokens or locking up tokens and assets to be sent across the bridge and back. And similarly, if you look at, those kind of all get grouped up into our collator node that are then submitted to the relay chain in relay blocks for our parachain. Similarly, there could be other parachains that want to interface with our parachain, and they could do so either through the orange kind of type of cross-chain message, if they're interested in just looking at assets that have changed and kind of asset transfer between Polkadot and Ethereum, or there'll be kind of lower level bridge APIs in the red if it's a parachain that wants more kind of customized application logic and integration with the bridge. And then similarly in the verse, you can see the red arrow where the Polkadot relay chain is the relay service is kind of watching the Polkadot relay chain, seeing new blocks and new things happening and submitting it through Ethereum in the same process in the inverse. So lastly, I want to talk about kind of usage today, progress in our roadmap. So our strategy has been to build an evolving MVP, defining our modular interfaces and getting a working MVP first. So this is kind of complete, and we have a working full two-way MVP with messaging and asset transfer and pallets, but the verification is semi-centralized, and we're evolving towards two things. One is to get our verification to be fully decentralized, so building out those Lifelines that I was talking about earlier, as well as integrating with Cumulus, integrating our cross-chain message passing interface and running as a full parachain as opposed to just our independent pallets. And so our core goal at the moment is a Rococo release, where we want to, within the next few weeks, release on Rococo, have our cross-chain messaging passing interfaces defined to allow for other parachains and applications developers to start integrating and actually getting this functionality themselves, as well as building out like full demo apps and a website that will make it really easy for people to see what's going on and to integrate with us. If we look at our timeline, as I said today,
Aidan, we've gone just 5 minutes over. Are you nearly finished to wrap up?
Yeah, I'll wrap up in a minute.
Okay.
Cool. So our timeline today is, as I described, we're hoping kind of in the next few weeks to do our Rococo release, for later in November to kind of get our initial trust minimization done, and late February is when we're hoping to kind of launch in production with Polkadot support. We are hoping to potentially launch earlier by scaling out our team, but we are dependent on when Polkadot is going to support parachains, and so in sync with that. And lastly, I'll leave the slide up for links and code for people that are interested in looking at our websites. You can see the Snowfork website and then our links to our GitHub repositories where we're developing our core functionality and our user interface. And then there'll be a better website with more documentation and details coming soon. Cool. Thanks, everyone. I'm done. And feel free to ask questions in the Discord chat.
Thank you so much, Aidan. No worries about going over time. I'm happy to give it 5 extra minutes. It was a great presentation and really interesting to see like how Snowfork are building these Ethereum bridges. So we're going to our next session with LimeChain. So I'll see you in there. And of course, as Aidan mentioned, he'll be on Discord, so you can continue to ask questions and connect with him further there. So see you in the next session.
Cool. Thanks, everyone. Bye.